All right, it's time to look at some special parallelograms and quadrilaterals. Let's start with one that's familiar, and that's a rectangle. We all know what a rectangle looks like. It's over on the right-hand side here. And a rectangle is a quadrilateral that has 4 right angles. They're 90 degrees. So we can see that little box in each corner marks that is equal to 90 degrees. So if a quadrilateral is a rectangle, it is a parallelogram. It fits all the criteria. And if a parallelogram is a rectangle, then the diagonals are congruent. So a rectangle has 4 right angles, and it has congruent or equal diagonals. Let's take a look at that now. As we're looking here at this parallelogram, ABCD, we want to prove it's a rectangle. Well, we're told it's a rectangle. We want to prove it using those two theorems. So first, we look at this proof by going through this statement. ABCD is a rectangle. That information is given to us. And angle A and angle C are right angles. And what we would put here is this is by the definition of a rectangle. Because our rectangle says opposite angles are congruent. A is equal to C because those right angles are congruent. And if we're looking at step 4 here, B and D are right angles, and this is by the definition of a rectangle. So that's what you would put here in the reasons. B and D are congruent because all right angles are congruent. So we know ABCD is a parallelogram because both sides of opposite angles are congruent. We're bringing everything back to these definitions. So now that we know it's a parallelogram, opposite sides are going to be congruent. And we see in this proof that AD is congruent to CB, and that the opposite sides are congruent. Now we look at number 8, and 8 says DC is equal to DC. Now, this is because we have divided it into two triangles. We're referring back to our triangle theorems as we are looking at these. DC is equal to DC by our reflexive property. And that's because we've used it twice up here in our diagram. We know angle D and angle C are right angles by the definition of our rectangle, and that D and C are equal because all right angles are equal. Now we can show that ADC is congruent to BCD by side angle side. And this is by our side angle side congruency. And now we know AC and BD are congruent. Because corresponding parts of congruent triangles are congruent. So we are bringing it all back to triangles and looking at these pieces and how we can prove a rectangle, which is a quadrilateral, 4 right angles, opposite sides are congruent, and the diagonals are congruent.